The map of our world is about to change.
A massive crack has opened up in Kenya seemingly overnight.
I'm talking about the continent of Africa splitting into two.
The ground does not always shout when it changes the world. Sometimes it just sighs, stretches, and opens slowly, relentlessly, until a map must be redrawn. In East Africa, a process as old as the planet is underway again. Rock is thinning, valleys are deepening, faults are lengthening, and far beneath deserts that shimmer with heat, molten rock is prying a continent apart. If you want to see how an ocean is born, you don't need a submarine. You need to look at a swath of land that is learning how to become sea floor. This story starts in a place geologists call a triple junction, a rare spot where three tectonic rifts meet like a letter Y. In the Afar region of northeastern Africa, the Nubian plate, the main body of Africa, the Somali plate, peeling away to the east, and the Arabian plate to the northeast are all pulling apart. From that point, one rift runs north into the Red Sea, another heads east into the Gulf of Aden, and the third, called the East African Rift, runs thousands of kilometers south toward Mozambique. It's one of the few places on land where you can stand inside the early stages of a future ocean. The rifting here is real, measurable, and steady. Using GPS and satellite radar, scientists have found that parts of the Somali and Nubian plates are moving apart at rates of only a few millimeters per year, about as fast as your fingernails grow. Yet in geology, that is plenty. Over millions of years, tiny motions add up to landscapes you can sail across. If you ask how we know this is more than theory, go back to September 2005. In the Ethiopian desert, a quiet stretch of crust suddenly declared its intentions. Earthquakes rattled the region for days. A fissure opened. In less than a week, magma forced its way upward and sideways along a 60-kilometer-long segment called Dabahu. Satellite radar showed that the ground had opened by as much as 8 meters, a split comparable in scale to events observed along mid-ocean ridges. But this time, it happened on land, where we could watch it like a laboratory experiment. That single sequence made something clear. Here in Afar, the processes that knit together new ocean crust are already underway. The 2005 intrusion injected an estimated 2.5 cubic kilometers of magma between about 2 and 9 kilometers depth. Only a small fraction of the deformation came from earthquakes. The main driver was magma wedging the crust apart. Exactly what maintains the long linear ridges that lace the seafloors of our existing oceans. To stand on the surface here is to walk across contradictions. The Erta Ale volcanic range looks like a run of low, dark hills until night falls and the mountain breathes. In the summit crater of Erta Ale, a lava lake, one of the few persistent lava lakes on the planet, has simmered for decades, sometimes for more than a century. Its heat patterns have been tracked by satellites. In recent years, fissure eruptions on its flanks poured out large fields of basalt that look, from above, like rivers frozen mid-flow. A short drive away, the alien palette of Dalol gleams under a white sun. This is a low sub-sea level hydrothermal field where acidic, mineral-rich waters rise through salt beds and paint the ground yellow, orange, and green. It is one of Earth's strangest landscapes. Some vents sit dozens of meters below sea level, and the air can feel like a kiln. It looks like a sci-fi set, but it's really a pressure gauge, telling you how thin and fractured the crust has become. So, what exactly is happening beneath the Afar deserts? The plates are diverging, and the crust is thinning. In the north, parts of the rift are already below sea level. The Red Sea and the Gulf of Aden, both formed by the Arabian plate pulling away from Africa, are essentially twin examples of what a young ocean looks like after rifting succeeds. Afar is the junction where these arms meet the continental rift that snakes south. It is a place in transition from continental rifting toward oceanic spreading. During the 2005 Dabahu episode, geophysical measurements showed that the crust here behaves less like a thick, rigid shell and more like something already prepared for oceanic processes. The crustal thickness beneath the Afar Depression can be as little as approximately 18 to 22 kilometers, thinner than typical continental crust, and it's heavily intruded by basalt. In size and spacing, the magmatic segments here resemble the block-like architecture of slow-spreading mid-ocean ridges. But the East African Rift is not one clean tier. It's a braided system with branches and microplates, and its southern limbs stretch past Kenya and Tanzania, embracing deep lakes like Tanganyika and Malawi. The rift system is often split into an eastern and western branch. Together with the Ethiopian Rift to the north, they form what geologists call the East African Rift System. The motions are small, but modern GPS networks can resolve them. 8 to 9 millimeters per year in some sectors, a few millimeters in others. Over time, that differential motion bends, rotates, and shears blocks of crust. One reason the map of African tectonics includes not just major plates, but also several microplates. One of those blocks, the Victoria microplate in East Central Africa, is famously doing its own thing. It's rotating counterclockwise relative to the rest of Africa, likely because of the patchwork of stronger and weaker zones in the lithosphere that transmit, focus, and release stress. In other words, the way ancient cratons and younger belts are stitched together influences how the rift opens today. This is another reminder that continents are not uniform slabs. They're mosaics, and mosaics don't break evenly. So, will a new ocean actually form? The careful answer is, very likely if rifting continues, but not soon on a human timescale. Many rifts stall, others succeed, and when they succeed, the endgame is straightforward. The land between the diverging plates subsides below sea level, seawater enters through the lowest saddles, and seafloor spreading establishes a new mid-ocean ridge between newborn passive continental margins. In East Africa, the northern sectors are furthest along. Two arms are already water-filled, Red Sea and Gulf of Aden, and the Afar Depression contains broad areas below sea level, primed by thin crust. Scientists often cite tens of millions of years for any true ocean basin to fill out, a number that sounds abstract until you remember the Atlantic Ocean began in exactly the same slow way. Recent research underscores that Afar's engine is complex. A mantle plume beneath the region appears to pulse chemically and thermally, channeling upwellings that interact with the rifting plates above. A behavior that could help explain the tempo of magmatism from the Red Sea to Ethiopia. That deep rhythm, measured in rock chemistry and expressed on the surface as fissures, cones, and lava fields, helps drive the transition from a stretched continent toward a spreading ridge. If you want to imagine the future coastline, think in possibilities, not promises. If extension continues, the Somali plate, which includes parts of Ethiopia, Kenya, Tanzania, and Somalia, would eventually detach from the larger African continent. Once the land between the Gulf of Aden and the northern main Ethiopian rift found a continuous low path to the sea, water would invade, and the earliest stage of an oceanic basin would form. In this scenario, countries deep inland today could become coastal over geologic time. But the real lesson is the process, not the prediction. Plates move and shorelines follow. To see why the ocean in the making is more than a catchy headline, return to the ground truth. The 2005 sequence. The Dabahu dike intrusion was not a one-off. It was the largest of a multi-year rifting episode that involved repeated magma injections and faulting events. The pattern mirrors what we know from Iceland and other ridge systems. Rather than one catastrophic tear, rifting often advances in pulses, each one intruding magma along the rift, each one prying the sides a little farther apart. Over time, the cumulative effect is to replace more and more continental crust with intruded and erupted basalt, oceanic-style material. In Afar, the grand forces of geology manifest in immediate, intimate ways. Earthquakes rumble frequently, some felt, many silent, while volcanic gases drift and sting, and the heat bakes the landscape. The Erta Ale lava lake glows continuously, sometimes overflowing or draining, while satellite sensors capture fleeting thermal anomalies as vents open and seal. This harsh terrain is both a natural laboratory for understanding continental evolution and a home for communities navigating the rift's hazards. The Dalal hydrothermal fields illustrate what happens when the crust is hyperfractured and thin. Boiling brines rise through salt, carrying iron and sulfur that form terraces and chimneys. Some vents lie below sea level, with chemistry so extreme that parts are sterile, while others host hardy microbes. A landscape on the verge of transformation. Viewed on a larger scale, the East African rift system stretches thousands of kilometers, reshaping rivers, ecosystems, and, over millions of years, climates and coastlines. Afar exposes features usually hidden beneath oceans, allowing scientists to observe in years what elsewhere takes millennia. The rift's mechanics involve more than plate sliding. The lithosphere is a mosaic of rigid cratons, weaker belts, failed rifts, and volcanic provinces, guiding the pace and pattern of splitting. Surface cracks may shift roads or fences, but most tectonic motion occurs kilometers underground, revealed through GPS, seismic waves, and satellite data. Events like the 2005 Dabahu Dike intrusion provide rare, clear glimpses of this hidden machinery, showing a complex living system in action, both violent and beautiful, immediate and epical. So what would a future African seaway look like? The early phase would resemble a narrow, elongated gulf, perhaps not unlike the Red Sea in its youth. Its edges would be steep in places where rift margins are high. In others, it would lap against salt flats and plains now baking in the Afar sun. Over time, as spreading continued, it would widen, develop its own transform faults and fracture zones, and carve a new identity into atlases. One more ocean added to a planet that has remade its surface many times. If that sounds far off, remember that every ocean you know started in whispers like this. The Atlantic began as a rift through a supercontinent. For millions of years, it was a line of basalt flows and small basins, not the blue expanse we see now. The same physics is at work in East Africa today. What's different is our vantage point. This time, we have satellites, seismometers, and geodesy, precise enough to watch the opening moves. The Afar deserts hold another lesson too. Change is incremental until it isn't. The rift advances in episodes, years of quiet, then weeks of activity, stacked over eons. The 2005 Dabahu sequence was one such burst. 163 earthquakes over a few weeks, a sudden dike, an eruption, and permanent extension locked into the crust. Multiply events like that by thousands, and you get an ocean. The math of plate tectonics rewards patience. Between events, the landscape bristles with signals. Erta Ale's lava lake rises and falls. Thermal anomalies wink on and off. Fissures lengthen. Small earthquakes tick like a metronome you can't hear without instruments. When lava erupts from a new fissure on a flank, it paves over old flows, building the rift's dark geometry, meter by meter. From space, the lava fields laid down since 2017 trace arcs and tongues that confirm the system's vigor, even in quiet years. Meanwhile, the chemistry of Afar's plume, studied in recent rock samples and modeling, suggests the deep engine is not a single column, but a pulsing source whose character varies with the thickness of the plate above and the rate of spreading. Think of it less as a blowtorch and more as a heartbeat. The crust responds in time with surges from below. That cadence could help set the schedule for future rifting episodes in the decades and centuries ahead, even as the ultimate ocean remains far beyond our calendars. What will people remember about this place a million years from now? Maybe nothing of the salt chimneys or the sulfur pools. Those will likely sit beneath water, buried under new sediments, colonized by life adapted to hydrothermal vents. The lava lakes will be long gone, their basins smoothed by marine processes. What endures is the architecture, a ridge, a line of new crust, a basin where the Somali plate once rested against the Nubian, today's deserts, tomorrow's seafloor. Until then, the Afar remains a frontier for science and a home for people. Researchers bring instruments to measure micromotions you can't feel. Locals bring salt out of the flats as they have for generations. One group reads the fault lines, the other reads the weather. Both understand that the ground here is never still. It is not a stage set. It is a machine humming, a reminder that Earth is not finished with its edits. When we say a new ocean is being formed in Africa, we're not predicting a cataclysm you'll witness next week. We're acknowledging the direction of travel and the mechanism pushing it along. Plates diverging, magma intruding, crust thinning, basins deepening, and, eventually, water taking the invitation. In the Afar Triple Junction, all the ingredients are present, and the first course is already cooking. If you want to understand how a world makes a sea, watch this desert. You are looking at the first chapter of an ocean's autobiography, and if the thought of maps changing unsettles you, remember that they always have. The continents you grew up tracing are drafts in pencil, not ink. Africa's story will include new margins and new tides someday, but its present says something quieter and more powerful, that creation and destruction are the same act at different scales, and that the slow, patient work of the planet is still in progress. Just enough for us to notice, just early enough for us to be amazed.